At this point, I'm pretty much done recapping the problems from the Project Euler streams. There are plenty more problems I could go over, but I think we're already getting into a point of diminishing returns here. The real value in this project is not something I can really pass on to you through a video. So I hope that the few that I've shown can give you some interesting ideas. I did go over some of the math / converting math into algorithms concepts that I used during those streams. And I exposed you a little bit of how the x64 particulars influence that work. But it's hard to really give a lot of the insights that you get from doing something like this in a video. There's not really any way to replace the value of firsthand practice. So if you want to learn x64, hopefully the main point of these videos will be to inspire you that it's possible to dig in and learn the x64 details by just practicing it. So I want to take a minute just to recap what I did practice and what I have left to practice that I think will be necessary for things I'd like to do in the future with x64. So things I did practice include I got through lots of signed and unsigned integer things, thinking about how different integer sizes actually work. So what happens when you set a register with 16 low bits and you don't set the upper 48 bits? What happens to those 48 bits? When you have to set the low 32 bits, it's a little different. What happens to the high 32 bits there? What happens when you read 64 bits out of something, but you didn't set all 64 bits in that register? There's a sort of performance penalty sometimes to composing portions of a register that you didn't actually fully set in one instruction. There are things like the ABI I got familiar with, so that's how function calls work, how you have to allocate a little bit of extra memory on the stack, not just for the return instruction pointer, but for what Windows calls the shadow block, which is some memory that it backs up the first 4 parameters. Even if you are passing those parameters as registers, you also have to allocate for them. This is also important to know how you find the location of further parameters, so the 5th, 6th, etc. parameters, how struct passing works, what it really means when you pass a struct, what it really means when you return a struct, and I appreciate a lot more what happens at the low level there and how the Model C gives you isn't quite honest. I knew for a long time now that when you pass a struct, there's a copy involved. But I didn't realize there was a copy involved and a pointer is still involved, so that you're also getting the same amount of indirection either way and an extra copy. So passing a struct is actually a lot more like an ABI that says the caller has the responsibility to make a duplicate of this thing before passing the pointer to me, because I may or may not modify it in place. And if you want to be protected from seeing the modifications I make, then the caller has to take the responsibility for making the duplicate. Whereas if there's a pointer parameter, that could either imply that we want to optimize out that copy, but we're not going to modify it in place, or that we do intend to modify it in place, right? So it's kind of interesting that the type system in C doesn't have that. Const in a way might be a way to try to express it, but it doesn't really work because it can be casted away, so you can't take it as a super strong guarantee. It's just kind of an interesting situation that comes up. If the language, for instance, didn't give you any way at all to generate modifications to a struct parameter, then you would never have to pass it with a copy at all. So it leads to like some interesting questions about what you would want to do. Of course, for C ABI compatibility, you'd still sometimes need to make a thing that copies a struct to pass it to a function, but it informs how I use C and how I would design my own little code generators in the future. Similarly, returning a struct has a bunch of interesting stuff that I learned. The struct has to get allocated by the caller, not the callee. The first parameter is actually a pointer to the return struct, and that function returns that pointer at the end. There's a lot of weird stuff like this that I learned by doing all this. I also learned how to formulate different types of control flow, specifically ifs and loops, as well as, being able to piece things together in ways that would be relatively hard to express using just ifs and loops. So when you're in C, you tend to try to make ifs and loops work because there's an advantage to making scopes work. But once you're down to assembly, the advantage to that kind of disappears, and things become a little bit more like control flow graphy. So what I mean by that is it becomes a lot more natural to just use labels and go-tos all the time and come up with techniques for making that make sense. And once you become familiar with that, it's sort of the building block to other concepts of control flow besides if and for loop that you might want to explore if you're building a generator for your own code, right? So that's some of the stuff I got a chance to explore. Some things I didn't explore in detail. I didn't get to do anything with floating point, so all the floating point instructions I didn't touch. And going in that same direction, since most floating point is done through SSE related instructions now, the SIMD instructions. I didn't do anything with those, whether the float or integer ones. I didn't get into any of the wide instructions. So those are definitely things that I would want to spend more time on in the future, because I think I would be interested in being able to generate stuff for floating point and wide instructions if I'm going to be doing CodeGen at some point. Knowing how that those instructions need to be fit together will be valuable to me. So I might do something else at some point to get another round of practice on SIMD in particular. We'll see. And something else I didn't get to do yet is do any of the control flow related to jump tables or virtual function calls / function pointer calls. In other words, I didn't do anything where I did a branch on a variable destination. So to implement a switch with a jump table or to implement function pointers, I would need to practice that. Now, I don't think it's something that would be too hard to get used to based on what I've already done. I just didn't happen to do any of those patterns, so I didn't see the details of how they work out yet. And so even though I know in concept how they work in the architecture, the fact that I didn't practice them means that there might be details about how you want to organize things around those concepts that I don't know about yet. So I do think I will have to go back and practice some of this stuff before I do serious CodeGen around any of those features. Altogether, I would say that I think this was a pretty useful way to practice, although I don't see how I would ever get around to practicing floats or the jump table stuff I was just talking about by doing Project Euler problems. So when I do go back to practice more, I'll need to find a different way to sort of derive the practice session than Project Euler problems, just because they don't really make any sense for using floats, because they tend to be involving number theoretic things, which is all about integers, and they just don't tend to be things that involve lots of case heavy stuff or like function pointer heavy logic. So it just doesn't come up a lot to do that kind of construct in the programming for those problems. But besides that, I would say it's definitely a useful way to practice the parts I did get a look at. So that's good. And I would recommend it to anyone who isn't too intimidated by somewhat advanced number theory. It's especially the early problems, a really great way to practice a new computation model. And that's all the thoughts I have on this project. I've got a new arc already in the works, and it's coming up soon. So see you guys then. Bye-bye.